Hi there, this is Andrea with my Week 7 Advanced Interactive Concept. I'm going to be showing the electron domain geometry and molecular geometry with balloons. Okay, so getting started, the total number of electron domains being 3 will be a type of molecule that is AB2. So the electron domain geometry is going to be trigonal planar. So having them all, let me back up. In one plane, we just have the 3 central atoms in the middle. Those are our 3 electron domains. There's going to be one lone pair, and so the molecular geometry is going to be bent. And show that with a different set of balloons. So it's going to be like this as a central atom, and then we have the 2 electrons, the one alone electron pair. Right here, it's kind of coming apart. Probably looks better like that. Okay. Then, okay, so just finishing up with that, an example would be sulfur dioxide. So then moving on to the AB3 type of molecule that would have 4 electron domains, then that would mean that it had a electron domain geometry tetrahedral. So 1, 2, 3, 4. The green color doesn't mean anything different. A central atom being in the center. There is one lone pair, so it's going to give us a trigonal pyramidal molecular geometry. So here's our central atom with the one electron pair right there, and this central atom is supposed to be in the center, but I can't really do that with the balloons. So just picture it down further. And an example of that would be ammonia. Okay, the third type of molecule will be an AB2 that has 4 electron domains, which would again be tetrahedral. And that if it has 2 lone pairs, then that's going to give us a bent geometry again. So just up here we have bent again, but with the 2 lone pairs, and because of their energies, they're actually pushing the bend a little bit more, so there's going to be a smaller angle with the molecules facing down, and that would be like something with H2O. Water. So the next one will be our, with the 5 electron domains, will be an AB4 molecule, so that's going to give us a trigonal bipyramidal. 1, 2, 3, 4, 5. Okay, so it's going to be our 5 balloons here. So kind of like the planar, but one balloon is up and one is down, but they're not really, here we go, like that. Like that, okay. And so there's going to be one lone pair, and that's going to give us a seesaw-shaped molecular geometry. So this is kind of like, okay. Again, the central atom should really be in the absolute center there. There we go. So it will be just in between these 2 balloons. But here's our lone pair, and you can see. All right, there we go. And an example of that would be sulfur tetrafluoride. So with the 5 electron domains, again, is a trigonal bipyramidal for our AB3 molecule. So coming back to this one. And when there's 2 lone pairs, we're going to have a T-shaped. T-shaped, yeah. So here we are like this with our 2 electron pairs right here. And then an example of that would be chlorine trifluoride. For the AB2, that molecule that has a 5 electron domain, we're going to go back to the trigonal bipyramidal. again. And when it has 3 lone pairs, it's going to be linear. So, okay, they're kind of scattered here, but that's going to be the molecular geometry that you're going to get. An example would be, the iodine fluoride ion. Okay. For the electron domain that has 6, it's going to be an AB5 molecule. We're going to go to the octahedral electron domain geometry of it. So there's 6 balloons here representing the bonds with the central atom in the middle. And when there is 1 lone pair, it's going to give us a square pyramidal molecular geometry. So here is our square. The central atom is kind of sticking out the bottom there. It should be on top. There's our 1 lone pair, and just like that, and then it's giving off its energy to distribute the charges. Okay, and then an example of that would be bromine trifluoride. And then the last one that we have, the AB4 molecule, is going to have 6 electron domains again. So that would be, okay, the octahedral electron domain shape. And that is our AB4 molecule. So there's going to be 2 lone pairs. And that's going to give us a square planar. So with this one, it's a little harder to show with the electrons on it because this central atom is supposed to be straight in the center. So we have an electron pair here, electron pair down here, but like I said, this should be kind of in the center here, so the electrons would actually be below it. And an example of that would be xenon tetrafluoride. Okay, thank you.